Okay, hi everyone. Let us now continue discussing about the language of sets. The next subtopic is about the subsets. A basic relation between sets is that of subset. When we say subset, that set is also, the members of that set are also members of the other set. For example, we have set A. Set A has the following elements. We have 1, 2, 3, 4, 5. The first 5 counting numbers. We have set B. Let's have the following let's have set B with the following elements. We have 2, 3, 4. As you can see here that 2, 3, 4 members of set B are also members of set A. So we can say now that B is a subset of A. B is a subset of A. But once this one is the elements of this one is more than the elements of this one, we can say that B is a proper subset of A. When we say proper subset, for example, we have set A and set B. We are going to let A and B sets. A is a proper subset of B if and only if every element of B is in B, but there is at least one element of B that is not in A. So in this one, meaning A has more elements than B. Because there are several cases wherein the two sets have the same number of elements. So we have set A as the following integers. We have 1, 2, 3. And then we have set D. For example, we have also x such that x is the first 3 counting numbers. So for example, we have these two, meaning D has also the first 3 counting numbers. We have 1, 2, 3. We have A is a subset of D. At the same time, D is also a subset of A. This is not a proper subset. So again, to make it now to for us to say that that is a proper subset, the elements of A must be more than the elements of B. But take note that all the members of B are also members of A. So, for example, in DCOMC students, there are first year, second year, third year, fourth year. So, meaning the all first year students are subset of DCOMC students. Okay, so let us have now this activity. But before that, let us now first understand some about the set of numbers. So let's have negative integers, meaning all of these negative integers are subset of all integers. All of these positive integers are also subset of all integers. And all integers are all rational numbers. This is subset of rational numbers. All of these are subset of real numbers. Let's have now the activity. Let set of A be positive integers. Say exponent plus that's pertaining to the set of all positive integers. We have set B. The elements are set of all elements N is an element of Z such that N is less than or equal to 100 but more than or equal to 0. So in set B, the possible elements will be from 0 up to 100 because of the symbol equal. Less than or equal to 100. 100 is included. And we have here the elements is more than or equal to 0. Therefore now 0 is also part of the set. from 0 up to 100. We have now set C. In set C, the elements are listed. We have 100, 200, 300, and 400. So you're going to evaluate the truth and falsity of the following statements. Is it true or false? Let us now answer. We have letter A. B is a subset of A. So let us now analyze. Set B from 0 up to 100. In set A, all positive integers. So this time, we can say that B, in set B, there is 0. But 0 is not positive integer. So, meaning this one is not a subset of A. This is false because B is not a subset of A. By the way, this is the symbol for not subset. Simply subset and a slash. So we have letter B. C is a proper subset of A. See here, we have 100, 200, all of these counting numbers. All of these are all positive integers, meaning all of these numbers or members are also members or element of the positive integers. So set C is the proper subset of A. Therefore, this is true for letter B. Letter C. C and B have at least one element in common. Let's now check. Set C and set B. We have set C. Elements are listed in Rooster method. We have set B. Set B from 0 up to 100. Therefore, the common element or members is 100. It has a common element, 100, meaning this is true. Okay, this is true. By the way, the common element is intersection of two sets. We'll learn that later about the set operation. So we have letter D. C is a subset of B. We have C, 100. These are the elements. Is the subset of B. So B. So it's from 0 to 100. Okay, as you can see now, 100 is only members of B. 200, 300 is no longer member. Therefore, this is not a subset. This is D is false. C is not a subset of B. Letter E. C is a subset of C. C, 100, 200. Okay, as we have said a while ago, that a set is a subset of itself. Therefore, now, a given set is a subset of itself. C is the given, and then it is a subset of itself. Therefore, this is true. All of the elements C are still elements of itself, of C. So, that's all. Later on, we'll learn about the set operation. Thank you for watching, and I hope you learned something.